Hello everyone, today we have a question from differentiation and integration. The first part involves differentiation and the second part involves integration. The source code for this paper is paper 1, variant 1, October-November 2024. The question says the diagram shows part of the curve with equation y equals to 12 over cube root 2x plus 1. The point A on the curve has coordinates 7 over 2, comma 6. So the question has given you an equation of the curve and some coordinates. Part A says find the equation of the tangent to the curve at A. Give your answers in the form y is equals to mx plus c. So the question demands an equation in the form of y is equals to mx plus c if you create a tangent at point A. So before I start the question, let me just draw a tangent at point A for your reference. This is the tangent. Now we know that a tangent is basically a line that touches your curve at one point only. So in this case, your tangent is going to touch the curve at point A. Fine. Now if you look at the form of equation that we are given, that is basically linear, and what is required in this question is just two things. First is the gradient, which refers to the variable m, and the second is the constant c. The rest y and x are given in the question in the form of coordinates. Now, one of the basic concepts is that whenever you have to find out the gradient of the curve at some particular point, what is the process? You just simply differentiate the given equation. So I'm going to differentiate the equation. Y is equals to 12 over cube root 2x plus 1. 2x plus 1. This is my basically the equation. Now I'm going to differentiate it dy by d of x. 12 divided by. The question is giving you the denominator in form of radical form. You are basically going to convert it into index form first before you start solving the question. So if I convert this into radical index form, this is going to turn out to be power 1 over 3. Now, as I have mentioned earlier before, a lot of times that whenever we are doing differentiation or integration, you can't basically differentiate or integrate a question when you have something in denominator. So the first step that you are going to do is bring everything from denominator into the numerator so that it is differentiable. So next step is going to be, I'm going to bring my denominator back into the numerator. So according to the rules of indices, my power is going to turn out to be negative. Fine. Now, in the next step, I'm going to differentiate it. So it's very simple. I'm going to shift the power. If I'm going to shift the power, this is going to be minus 1 over 3 multiplied by 12 multiplied with the original bracket, that is 2x plus 1. Now I'm going to subtract 1 from the power and I'm going to multiply it with the differentiation of the internal bracket, that is 2x plus 1. The differentiation of the bracket is going to be 2. So now I'm going to cut the values, and this is going to be 3 1s and 3 4s. Now this turns out to be 4 1s or 4 2s are minus 8 bracket 2x plus 1 minus 4 over 3. This is my differentiated equation. Now the standard form of giving the answer is you need to give your final answer in form of positive power. So what I'm going to do is I'm going to take this bracket along with its power back into the denominator. This is going to turn out to be 2x plus 1 power 4 over 3. This is my final differentiated answer. Now this particular equation dy by d of x is now the gradient of curve, provided that you have a specific point where you have to find out the gradient. In this question, we are given point A where we have drawn the tangent and we are supposed to find out the gradient. The coordinates of point A were 7 over 2 and 7 over 2 and 6, if I'm not wrong. What I'm going to do is I'm going to put the values into the differentiated equation. So this turns out to be minus 8 over 2, x is 7 over 2, plus 1 power 4 over 3. Now with the help of calculator, you are going to find out the answer. The answer is going to be minus half. This is my gradient of tangent. The tangent that I have drawn at point A, the gradient of tangent turns out to be minus half. Fine. Now coming to the next part, we have to find out the value of the variable c. So I'm going to write the equation, that is y is equals to mx plus c. mx plus c. We know the values of variable y, we know the value of m, we know the value of x. The only thing that is left in the equation is c. I'm going to put all the values into the equation and find the value of c. Y is 6 according to the question that is given to me. Y is 6. M is minus half that we just calculated. X was 7 over 2. And C is the respective variable that you were supposed to find the value of. So with the help of calculator, C turns out to be 31 over 4. 31 over 4 is the value of C. So the final answer that you are going to write for the examiner to check is going to be in the form of y is equals to mx plus c, because that is the required part of the question. So this turns out to be minus half, that was the value of gradient x, and the value of c is 31 over 4. 31 over 4. This is the final value, or the final answer for part A. That is the final answer for part A. I hope you understand this part of the question. Now coming to part B. Part B says find the area of the region bounded by the curve and the lines x is equals to 0, x is equals to 7 over 2. So the question has given you the limits, that is x is equals to 0 and x is equals to 7 over 2, and the question basically is asking you to find the region, to find the area. What is the method of calculating the area? We know that whatever the curve is given in the question, whenever you find out the area, it's always area under the curve. It's always area under the curve. So the area that I'm highlighting right now is basically the intended part that you are supposed to find out in the question. This is my area. Fine. You are basically going to integrate the equation that is given you into the question, and you are going to basically apply the limits and find the area that is under the curve. So I'm going to write my equation, that is y is equals to 12 over cube root 2x plus 1. 2x plus 1. Now as I've mentioned above, that you can't basically integrate or differentiate something that is in denominator. So the first step that I'm going to do is bring everything back into the numerator. 12 multiplied by 2x plus 1, and powers was minus 1 over 3. Minus 1 over 3 was the power. Now how do you integrate? The step that you are supposed to follow for the integration is very simple. You just basically add 1 to the power, divide it with the same power, and multiply it with the differentiation of the bracket. So that is what I'm going to do. This is going to be 12 as it is, 2x plus 1. I'm going to add plus 1 to the power, that is minus 1 over 3 plus 1. And I'm going to divide it with the same power, which turns out to be, in this case, 2 over 3 with the help of calculator. And I'm going to multiply it with the internal differentiation of the bracket, that turns out to be 2. So after simplification, this turns out to be 12 2x plus 1 2 over 3 over 4 by 3. Now if you wish to simplify the denominator, that because there is a fraction in there, so if you want to remove the fraction, the answer is going to be 9 2x plus 1 2 over 3. This is your final integrated answer. The final integrated answer. The next step is you are supposed to apply the limits. The limits were 7 by 2 to 0. You basically write the higher limit first and the lower limit after. Now the formula to find out the area is that you basically subtract the lower limit from the higher limit. You're going to subtract the lower limit from the higher limit. What I'm going to do is I'm going to put in the values of x, the limits that were given to me in the question, that were 7 over 2 and 0. That is 9, 2, x is 7 by 2 plus 1 power 2 over 3, and I'm going to subtract it from 9, 2x is 0 plus 1 power 2 over 3. So with the help of calculator, I get the answer 36 for this part minus 9 for this part. So the final answer is 27 units square. This is the final answer for the area under the curve that is given to you in the question and the area that I have highlighted. So I hope this question is clear. That was question number 7 for October-November 2024 variant 1. If you have any questions, please let me know in the comments below. Thanks for watching, and I'll see you in the next one.